He kōna I purangi tēnei nā te reo irirangi o Aotearoa.
Voice of Tangaroa is a collaboration between New Zealand Geographic and RNZ. Reporting for this series is public interest journalism funded through New Zealand On Air.
They're big birds. They're sort of, if you were standing, they're about your mid-height. And so they feel a bit like people, really.
We kept on kidding ourselves like that for a few years, and then of course you realise, no, they're not coming back, they're dead.
Incidental fisheries bycatch is still by far the biggest issue that's going on.
New Zealand needs to lead by example because we can't tell other countries to increase observer coverage or use mitigation measures if we're not doing it ourselves.
Kia ora, ko Glegan Cavan tēnei. Welcome to this bonus episode of Voice of Tangaroa. We've been bringing you ocean stories through a collaboration between Our Changing World, which I produce and present, and New Zealand Geographic. In telling today's story is Rebekah White. Kia ora, Rebekah.
Kia ora. I'm an editor at New Zealand Geographic and a science journalist, and last year I wrote a story about a pair of researchers who've been counting albatrosses on remote islands in the subantarctic for more than 3 decades. Their work shows that at least one species is in danger of becoming extinct, but some changes to fishing rules could help. The question is whether or not we'd make those changes. But first, let's introduce the stars of the show. Birds and humans.
There's a group of birds called wandering albatrosses, and in New Zealand, nesting in New Zealand rather, we have 2 of them. So we have Gibson's wandering albatross, which nests on the Auckland Islands, mostly on Adams Island, and then we have the Antipodean wandering albatross, which nests on Antipodes Island.
They look rather different than each other, the Antipodes and the Gibson's albatross. The one on Antipodes Island, the females are a sort of chocolate brown with a white face, whereas the males are white with a little black cap and black wings. On the Auckland Islands, Gibson albatross is much whiter, both the males and the females. And they're big birds. They're sort of, if you were standing, they're about your mid-height. And so they feel a bit like people, really.
This is Graeme, Elliott and Kath Walker. They both work for the Department of Conservation. Graeme on a few things related to birds and predator control, and Kath mostly on large land snails, Pauliphanta. But also, for the last 34 years, Graeme and Kath have made a trip every summer, sometimes as part of their work, sometimes using their annual leave, to travel to either Adams Island or the Antipodes Islands to study albatrosses. The first time they counted albatrosses was on Adams Island in 1989. But they'd gone there with a different bird in mind, a type of bird called a rail.
We went down there to try and find a little rail, which hadn't been seen for 20 or 30 years. And the little rail turned out to be really quite easy, and we found it within a few days of arriving on the island, and we were there for 6 or 8 weeks. So we were trying to figure out what else we could do that was useful. And at the time, the wandering albatrosses had been starting to be recorded as a big bycatch in the southern bluefin tuna fishery, and we knew that lots of them were being killed, and so we were worried that the population might suffer. So we thought the right thing to do is to try and count them. So we had a crack at counting those birds in 1989, but we did a really bad job. It was the wrong time of year. They were just chicks. The adults weren't present, and we didn't know how to count albatrosses in a great big sort of mountainous environment. So we went home, realised that what we'd done was rather rubbish, and figured out how to do it properly, and then came back again in 1991 to have a go at doing it properly. And then pretty much every year since then, we've been trying to do it properly.
I'm always amazed by how tricky it is to get good data about how many birds there are in a population. And it's the breeding pairs you really want to count, right?
Yeah, but with albatrosses, this is tricky too because they don't lay an egg every year. This is how an albatross life goes. On Adams Island, eggs are laid around January and hatch in April. But it takes a year to raise a chick to the fledgling stage when it's able to fly.
So they leave the island a year after they were laid, basically. And then they go out to sea, mostly to the Tasman Sea, where they stay for the next 3 or 4 years until they come back to the Auckland Islands. And then they come back for probably another 10 years, during which time they're mostly courting. So they've got all this fancy dancing and singing stuff they do which helps them find mates. So they come back to the island, they do that for many, many years, and gradually they sort of settle on one partner and settle down.
So 10 years of hanging out and chatting and flirting?
Yeah, basically, until they find that mate. So, well, some birds can breed as young as 8. 12 is the average age that they start. And you want to know how many birds are breeding, because what's important is whether the population is going up or down.
Once they've started breeding, so they lay an egg, it takes a whole year to raise a chick. And after they've raised a chick, they have a year off because they need to go away and molt and put on a bit of condition so they can do it again. So it's every second year, once they've started breeding, they're back at the island.
And as for how long they live,
Well, we haven't been studying them long enough to run out of ones that we met as adults in 1991. So some of those are, 44 years old.
Actually, amongst the birds, I can't remember which island it's on, but there's a 48-year-old bird that was banded by others before we started doing the work. So they certainly last for 50 years and probably 60 or 70.
when they came back to give it a proper go in the early 90s, Kath and Graeme did whole island counts, traipsing up hills through the tussock and megaherbs to visit each breeding pair on Adams Island. But it was tough going.
There's a band, and on Adams, it's about 4,000 hectares that we have to walk around in. So if you want to count the whole thing on the ground, it takes bloody ages, and it requires quite good weather because you've got to be able to see. The weather in the Auckland Islands is usually atrocious, so it's often quite hard to see.
So in 1998, they switched to a new method. They picked 3 spots on both islands that represented about 10 or 15% of the total area. Spots that were easy to get to. So once eggs are laid, they go and count every pair with an egg and then extrapolate out those numbers to estimate the whole population. They also have smaller sites where they do mark recapture studies. That means every adult bird and then every new chick hatched in those places gets a leg band so that they can keep track of them across the years.
So the main focus of our mark recapture study is to estimate adult survivorship, because of course that's the thing we're really worried about, birds being killed at sea. So we use the mark recapture stuff to estimate adult survivorship, and we also, in our mark recapture study area, we find all the nests and we mark the nests so we can come back a year later and see whether, there'll be a chick on it, so we can see that the chick was successful in fledging. We can not only measure who lives and dies and the survivorship, we can measure the productivity, who nests, and who successfully raises a chick.
And while the intermittent breeding of the albatrosses makes Kath and Graeme's research a bit trickier, the birds do have one characteristic that helps.
They always come back to where they were, particularly the males. So if a bird, particularly a male, doesn't turn up, it's because he's dead. The females are a little bit more fickle, and if their mate dies, they might move a few hundred metres, but you can still usually find them.
And that starts from, the chicks spend 9 months on their nest when they're being raised, and when they first come back to the island, once they've had their, 3 to 5 years as juveniles, just getting their sea legs, sea wings, when they first come back to the island, they inevitably come back pretty well to where they spent those 9 months, within a few 100 metres, tens of metres. It's pretty amazing. They must all be related in a small area, uncles and cousins and
grandparents, yeah.
So the birds keep coming back to where they were born, and Kath and Graeme keep showing up year on year. It must be like greeting old friends.
Yeah, they even have rules around that. So when you approach a bird, especially one on a nest that might get startled and crush its egg, you have to say, hello.
The thing about what Kath was saying before about them being sort of our size, sort of dog size really, is you end up thinking of them as kind of people and talking about them like that, so your courtesy seems important. And they're really quite polite, mostly polite birds amongst themselves. They've got protocols for greeting each other and dancing and courting, which we can't do very well, but at least we can be polite. So yeah, it's very anthropomorphic, but we do it.
This summer just gone, with the support of Doc, they've tried something new, using drones to do a whole island count. The first one they've done since 1997. And while Kath and Graeme were on Adams Island, Kalinka Rexahuber of Parker Conservation was looking after the Antipodean Island side of things.
we're actually doing three things. We're doing the drones to take aerial photographs. And in that area, while the drones are flying, we've got ground truthing to check what proportion of those birds you can see in the drone photographs actually have an egg under them, because you can't tell that from a drone photograph or any kind of aerial photograph. You just can't tell. And that's actually a not insignificant proportion, so we really have to correct for that. But it's also quite variable, so it needs to happen at the same time as the drone's flying. On top of that, though, we're also just doing ground counts, as in moving in strips across the landscape, counting every bird you find, moving 25 metres down the hill and going back and counting every bird you find 25 metres. So there's a lot of ground counting in that sense also, every single bird you find over a large area.
The ground count will allow a direct comparison to the 90s counts because it'll be done in the same way. But verifying the drone data might mean they can use drones in the future, especially for those tricky bits. I mean, when the weather lets them.
Howling fog is a real phenomenon on these islands, where it's blowing so hard that you would think the fog would blow away, but it doesn't. It's just howling fog, and you can't actually see albatrosses under those conditions. So we hope for a bunch of good weather.
So we've got 2 islands with different albatrosses and 30 plus years of study. What's the data showing? How are these birds doing?
Well, at first they seem to be doing fine.
Yeah, well, at the very beginning, the numbers were low, but then they were rising. So for the first, more than 10 years, I suppose, the numbers of albatrosses were rising. And we think that was because they'd been killed in large numbers in the southern bluefin tuna fishery, and the tuna fishery had collapsed a bit, and the fishermen had got their act together a little bit. And
we had avoiding mechanisms, and the joint Japanese fleets had departed, joint venture things, and so the amount of fishing was less, and they were so between sort of the late 90s through to 2005, apart from a couple of little blimps, they were the numbers were increasing. We were feeling more comfortable about it.
And the ones on Antipodes were rising really quite steeply. It was sort of a bit unbelievable. And the Auckland Island ones, Gibson's albatross, were rising just slowly, but it was positive. There was nothing to be worried about. Things were looking good.
Oh, Rebekah, I can feel a but coming.
Yeah, there is. At this stage, Dock and Fisheries New Zealand, who'd been paying for the study, pulled the funding. I mean, things were positive, the birds were okay, time to reprioritise where the money goes. Kath and Graeme, though, went back in 2006 anyway.
Suddenly the populations, both of them, essentially halved. And of course, at first we thought, they've just decided not to breed. And
poor conditions at sea. They're not can't breed this year. They'll be back the next year. Next year.
And we kept on kidding ourselves like that for a few years. And then of course, you realise, no, they're not coming back. They're dead.
Do we know why this crash happened?
Not fully. From what they could see on the island, there was something going on at sea with the birds' food. Chicks were dying on the nest, and not just the ones where a parent had disappeared. Even those that still had 2 adults trying to feed the chick. There just seemed to be a lack of food. But, of course, they needed to know whether this was a blip or a trend. And so they kept going. For a few years it was off their own bat. They called in favours, hitchhiking on scientific vessels and with tourist expeditions, cobbling together funding from various sources and roping in others to help. The study continued.
Since then, the Antipodean birds have sort of continued to trickle slowly downwards still, and perhaps the Auckland ones have recovered a bit more, but they haven't made up any ground. That's just
the numbers are still half what they were prior to 2005. And there's on both islands, females seem to be lost at a higher rate than males, even from the beginning, I think.
Yeah. So on both islands now, there's an awful lot of older male birds standing around waiting for their mate and hoping to pick up a new mate, but there's a shortage of girls, so they're not going to get one.
Yeah, that's pretty sad for the males. And it must be hard for Kath and Graeme seeing this unfold on the island, but not knowing what's happening to the birds out at sea.
Well, they're starting to understand that better too. As technology has advanced, they've taken advantage of it.
We started doing satellite tracking, didn't we, to try and see where the birds going somewhere different, that they weren't getting enough food. We'd done some studies of where they foraged at sea before the crash. And so we started doing some tracking at sea after the crash. And for the Antipodes birds, we found, yes, they were going further and going in different directions. And yet their breeding success was 10%, 15% lower than it had been. It looked like they were working harder, but getting less for it.
And we also, with the tracking the birds, we also got a lot more information about their interaction with fishing boats.
The thing is, you can't really tell what's happened in this interaction, taking place somewhere out in the big wide ocean. Kath and Graeme use a website called Global Fishing Watch, which tracks fishing vessels around the world by their automatic identification systems. They look at the track of where the tagged albatross is going, and then they look at the map of where fishing boats are going, and then they can see when bird and boat cross over and the tag drops out. But the tags can fail and run out of batteries, so maybe this is pure coincidence. Except once that was definitely not the case.
2 birds we could see met a boat, and we managed to talk, or via New Zealand fisheries officials managed to talk to the fisheries officials of the nations whose boat seemed to have coincided with our bird death, and we got the satellite tags and the band numbers back from the birds. Yes, they'd caught them.
Yep. And one of those boats was really interesting and informative because they gave us back the transmitter and the bands of the bird that had been on the transmitter, and they also gave us back the bands of another bird that they'd caught within a few days of the one with the transmitter.
Which wasn't wearing a transmitter, which we wouldn't have known about because we
otherwise.
have a transmitter.
And that sort of, well, for me anyway, it really brought it home that large numbers of the birds were being killed because we only mark about 2% of the total population, and this one boat had caught 2 of our banded birds in a very short period of time. And of course, there's no incentive for those fisher folk to let us know that they've caught birds. It's probably more of an incentive to not let us know that they've caught birds. So it's rather remarkable that one of these boats killed 2 birds in quick succession, and the 2 birds that they told us about were both banded, and yet only 2% of the population is banded. If you sort of do the sums on this, it makes you realise that boat probably killed many tens of birds, and only a couple of them were banded. That sort of brought it home to us that the fisheries bycatch problem was still a big issue.
Oh, wow. That must be quite confronting for Kath and Graeme. To be sent back bands and a tag as all that's left of birds they've been studying. And I guess if it's a parent, then the chick has no chance that year, and its mate is also at a loss for years to come.
Yeah, and look, before we wade into fisheries bycatch, which we're about to do, we know that it's not the only threat that the albatrosses face. Here's Kalinka again.
We know that changes in how the planet's looking and how the circulatory systems are and the warming patterns in the oceans, the oceanic heat waves, all of these things affect where the prey is, and as that changes, the birds might need to forage further, or they might be able to forage closer and they might be okay. But there's a lot of changes that are happening with them, with climate change, that will be influencing these birds also. And then plastics at sea is certainly a thing. We know from the tracking data that Antipodean albatrosses, some of the areas they forage do overlap with some of those really high plastics concentration zones. Not as badly as it is for some of the albatrosses, but we find plastics up in the study area that have been imported by the birds, a case of mistaken identity, and so it's brought back for the chicks to eat, which doesn't always end well. To be honest, though, the incidental fisheries bycatch is still by far the biggest but tackleable issue that's going on.
Yeah, and it feels like it might be an easier thing to address than climate change. I mean, not to say that it would be easy, but just that reducing bycatch would have a guaranteed direct positive result. Less dead birds. But back to that story about the tag on the boat. I mean, it's a requirement to report bycatch in New Zealand waters, but if you report it and it means that fishing restrictions get put in place, are you essentially shooting yourself in the foot? But without proper bycatch reporting, we can't possibly understand the scale of the problem or figure out what we can do to reduce it.
Yeah, exactly. You've got to know the full extent of the problem first. New Zealand fishers reported that they caught 1,328 albatrosses over 4 and a bit years. That's all albatrosses. We don't actually know how many of those are Antipodean or Gibsons. But we do know that this is likely an undercount because bycatch numbers always go up when there's an independent person or a camera recording.
Well, the first of the government's long-awaited cameras on inshore commercial fishing boats are about to go live.
That was July 2023. As of mid-January this year, all surface longliners operating in New Zealand waters were required to have onboard cameras. About 2/3 of the fleet installed them. Then, in mid-February 2024, Oceans and Fisheries Minister Shane Jones announced the further rollout of cameras on fishing boats was under review. But if the cameras stay on the boats, it may be that soon we'll be able to better understand the full scope of the problem.
And we've got some preliminary data on this already. MPI released an update on the 1st of April 2024 where they looked at the vessels that now have cameras on board and compared their reporting from before and then after the cameras. It's a total of 123 vessels, 101 inshore trawl and setnet boats and 22 surface longliners. And they found that reporting of albatross interactions has gone up 3.5 times since the cameras were installed.
And in Australia, sea mammal and bird bycatch increased 8-fold after the addition of cameras to longline vessels in 2015. The New Zealand government has a goal of zero bycatch by 2050, but it doesn't have a path towards achieving this, mostly because we don't have good information about what's being caught and where. If we knew, we could make stricter rules in some places and relax the rules in other places. For albatrosses, the main fishery that's the issue is surface longlining for tuna. It's where lines are baited with squid and laid on the surface of the water. And these lines can stretch up to 100 kilometres long and carry thousands of hooks. And of course, the hooks don't discriminate. Squid is a tasty treat for an albatross, and caught birds drown as they're dragged underwater by the sinking line. But people have investigated how to minimise albatross bycatch, and there are some methods that help.
Things like bird scaring lines, which is basically just a cable with some streamers on the back of the ship.
This is seabird expert and Pacific Regional Coordinator for BirdLife International, Dr. Stephanie Burrell, speaking to Morning Report.
Using weight lines so that the weights drop down into the water much quicker than they do without them and out of the reach of the seabirds, and setting at night so when the birds aren't active. And these are all really easy things that can be done to avoid seabird bycatch, but the vessels just aren't doing it.
So the agreement on the conservation of albatrosses and petrels, which New Zealand is a party to, advises that best practice is to implement all 3 of these measures simultaneously. But in Aotearoa, our regulations only require 2. Some New Zealand fishers voluntarily do all 3, but climbing bycatch numbers and the evidence we have from onboard observers indicates that many don't, or they don't use them properly. There's this extreme example from 2016.
A commercial fisherman will be prosecuted over the deaths of 38 albatrosses. The birds died off the west coast in April. The Ministry for Primary Industries says the fisherman, who was fishing for southern bluefin tuna, failed to use a mandatory device which scares birds away from baited hooks.
In 2022, government observers checked 3 surface longliners out of a fleet of about 30 boats, and none of the 3 was properly following the rules. They were doing one of them, using bird-scaring lines, but not using them properly. One line was ripped off and the vessel kept fishing. Another crew couldn't get the streamer line to fly above the long line, which meant it didn't scare birds in the right place, and a third line was too short. 2 of the vessels didn't report bycatch properly, and 2 of them caught large numbers of seabirds.
But this is just our patch of ocean, right? These are wandering albatrosses that can cover massive distances.
Yes, you're dead right. Here's Kalinka Rexahuber again.
To feed a chick can be thousands of kilometres, just a little pop-out to feed the family, which means that they encounter fishing fleets all over the oceans in all sorts of jurisdictions, like in the exclusive economic zones of all sorts of different countries, in the high seas. So it's not as simple as just working with one country and their fisheries regulatory bodies to try and make some changes there and reduce the number of Antipodean albatrosses caught. It's a very large international sort of a challenge to get changes happening.
And remember that gender imbalance in the deaths.
One of the outcomes of that population crash was that there's lots more males than females because female survival was so bad and lots more females got affected.
Based on their data, Kath has a theory about what this is due to.
The females are about 1 kilogram lighter than the males and smaller. That's for both Antipodean and Gibson's albatross. And they forage further north in lighter winds and tropical seas than the males, which tend to go south of the subantarctic, even as far as Antarctica, because they can handle the stronger winds in the furious 50s and so on. So the sexes are feeding in different places. And the fishing fleets that they've been caught in are long-line tuna boats, which are mostly in the tropical waters but come down in the winter time closer towards where the female wandering albatross and the juvenile wandering albatrosses from New Zealand feed. So that's why the greater interaction of boats and female birds.
To solve this requires agreement across international fisheries. And Stephanie, from BirdLife International, who acts as an observer at meetings, says there isn't a lot of interest from other nations in solving the bycatch problem. Tuna stocks are back on the rise, so the industry plans to increase fishing effort, which will probably increase bycatch in turn. But, she says, the fact that bycatch is happening outside our waters shouldn't be used as an excuse for us not to get better.
New Zealand needs to lead by example because we can't tell other countries to increase observer coverage or use mitigation measures if we're not doing it ourselves, and we can't prove that we're doing it ourselves.
In the meantime, Kalinka, Kath and Graeme remain focused on gathering the information needed on how these birds are doing.
We have fun counting the birds each year, and we've found out this really depressing story, but the actual work to fix it has got to happen by a different kind of people than us. You know, it's got sort of diplomatic and persuasive.
The satellite tracking has really helped enormously because it's made a bit that connection from what's been happening on the island, what you can see just on the breeding grounds when they come back once a year. It's made a really important difference to connecting the dots. So we've been trying to ensure that the information goes to MPI and other agencies which can start talking to the fishing fleet, and the whole lot is sort of connected at last.
Fisheries bycatch isn't the only threat these albatrosses face, but it's one that we've got the knowledge and the tools to do something about. So maybe we should just do it.
This episode was reported by Rebekah White for New Zealand Geographic and me, Claire Kincannon. Thanks to the people featured: Graeme Elliott, Kath Walker, Kalinka Rexer-Huber and Dr. Stephanie Burrell. Voice of Tangaroa is a joint production between RNZ's Our Changing World and New Zealand Geographic. New Zealand Geographic reporting on the Voice of Tangaroa is public interest journalism funded through New Zealand On Air. Live Ocean Foundation supported some of the travel costs for this story. This episode was produced by Rebekah and me, with help from Ellen Rikers and Brianna Uritich. Thanks to senior producer Phil Vine for editing help. Sound engineering was by William Saunders, and executive producers are Tim Watkin of RNZ and James Frankham of New Zealand Geographic. Original music for this series was created by Grains. Tēnā koe I whakarongo mai. Thanks so much for listening. Ko Claire Kincannon ahau, mā te wā.